Here's our third lesson on finding inverse functions. This time our function is g of x is equal to 12 minus 4x over 3. And we are tasked with finding the inverse of this function. So step one is we let the function g of x equal y. So we end up with y equals 12 minus 4x over 3. And what we need to do now is we need to isolate the x. Now, in order to isolate the x, the first thing we've got to do is we have to undo the divide by 3. To undo a divide by 3, we're going to multiply our equation by 3. So we end up with 3y is equal to 3 on 12 minus 4x divided by 3, and the 3's are now going to cancel. So we end up with 3y is equal to 12 minus 4x. Remember, the whole point of this exercise is to get x on its own. So we're going to bring the minus 4x to the left-hand side and get 4x equals, and the 12 is staying put on the right-hand side, and we're going to bring the 3y over to the right-hand side, and it becomes minus 3y. Finally, we've got 4 times x, so to undo the 4 times x, we're going to divide everything on the left by 4 and everything on the right by 4, and we end up with x is equal to 12 minus 3y over 4. We now need to use the inverse notation, and remember we started off with g of x, so therefore the inverse notation for this is going to be g minus 1 empty bracket equals 12 minus 3, and where you see the y you put an empty bracket and then divide your answer by 4. To finish this off, you put inside the empty bracket the letter x, and then you end up 12 minus 3x over 4 is your inverse function. So that's the end of part 1. Now part 2 is asking us to actually test this. So what they're asking for part 2 is that we actually test this inverse function using x equals 2. Now, how do we do a test? Well, it's very simple, really. We know that it has to be a bijective function. So what we have here is we're going to have x is going to go to g of x. So we're going to see what 2 becomes over here, whatever value it becomes. And then what we're going to do is we're going to use the inverse function g minus 1 of x in order to bring this value back. And if it's a proper inverse function, it should bring us back to the same value of 2. So that's what we're going to be doing. We're going to see whether the value we get can be brought back to the initial value of 2. So test the result. This is part 2. Test the result using x equals 2. If you ever ask this question, then this is what you do. So you're given x is equal to 2. You know that g of x is equal to 12 minus 4x over 3. So now you've also got the empty bracket version of this, which is 12 minus 4 on empty bracket over 3. We have the inverse function. So the inverse function of x is equal to 12 minus 3x over 4. And the empty bracket version of this is 12 minus 3 empty bracket over 4. So what we're going to do now is we're going to test using the function x equals 2, which means we're going to be using the empty bracket formula. And we're going to be substituting into this empty bracket the value of 2. And when we work out the right-hand side, we're going to get 4/3. So our output number is 4/3. So what we do now is we have to see whether using the inverse function that brings us back to a value of 2. So since we've got two versions of the function above, the x g minus 1 of x version and the g minus 1 empty bracket version. And we're going to be using the empty bracket version as we've seen before in the course. And we're going to be putting 4/3 in place of the empty bracket. And when we do that, we have to do this carefully. So 3 on 4/3 will give us 4. So that becomes 12 minus 4 over 4. 12 minus 4 over 4 is 8. So it's 8 over 4. And 8 over 4 is 2. So what we have shown is that the 2 using the g of x function goes out and gives us a value of 4 over 3. And the g minus 1 function of x brings us back. So therefore we've shown that the inverse certainly works for 2. Now for part 3, give a chance to pause the video there and copy down the work that you've got there on the right hand side for part 2, because I'll be rubbing some of it out and I'm going to be continuing now with part 3. So a classic way of showing that one inverse, that function is inverse of another, is to do g on g minus 1 of x and show that the answer is x, show that it comes back to where it started. So we'll do that now. So just rub out this numeric version. So we've seen composite functions before, so let's just explore this one. So here we go. We've got 4 formulas. Formula number 1, formula number 2, formula number 3, and formula number 4. And the first thing we've got to work out is g minus 1 of x, which is in actual fact formula number 3 above. So therefore we can substitute straight in the answer for formula number 3. Now don't forget, when you substitute something in, you always substitute into brackets. So what is g minus 1 of x? Well, we know it's 12 minus 3x all over 4. And then we close our bracket. Now, we need to work out g of this value. So we're now going to be using either equation 1 or equation 2. Since what's inside the bracket is not an x, we are going to use the empty bracket version. And the empty bracket version for g of x is 12 minus 4 on an empty bracket, all divided by 3. And what goes in that empty bracket? Well, this value here goes in the empty bracket, so we're going to write that straight in. So we've got 12 minus 3x all over 4. So that's the first bit of the working out done. Now, fairly obvious, if we multiply the 4 onto the bracket, it's going to cancel with the 4 on the bottom. So this is a relatively easy bit of working out. So this now becomes 12 minus open bracket 12 minus 3x, because the 4's cancelled with the 4's. Please note I've still left it in brackets. I've only cancelled the 4's. What we have now is running through with the minus sign. We end up with minus 12 plus 3x and all over 3. The 12 minus 12 cancels, so we end up with 3x over 3. And of course, when you divide by the 3's, you end up with the x. So we've shown that g on g minus 1 of x is equal to x. What we're going to do now as an extra, it wasn't part of this particular question, the way I've set it up, but we are going to have a look to see if the same is true if we swap the g minus 1 around with the g. So we're going to do it this way now. So first of all, again, using composite functions, I am actually going to work out g of x first. And since it is g of x, it's equation number 1. So all we've got to do is substitute the answer into a bracket. So what is g of x? Well, g of x is, if we go and look up here, is 12 minus 4x over 3. So we put in here g of x is 12 minus 4x all over 3. We're now going to be using the g minus 1 formulas, which there are 2. And don't forget, we use the empty bracket version in the case when what's inside the bracket here is not an x. And this is clearly not an x, it's 12 minus 4x over 3, which means we're going to use this empty bracket version. So therefore, the empty bracket version is equal to 12 minus 3 on an empty bracket all over 4. Now what goes inside that empty bracket is 12 minus 4x all over 3. This bracket has been multiplied. This bracket has been multiplied by 3. So this 3 and that 3 will cancel. So we're left with 12 minus, because the 3's have cancelled, we're just left with the 12 minus 4x inside the bracket all over 4. And then we're going to lose the bracket, so 12 minus 12 plus 4x all over 4. The 12 minus 12 cancels out to give us 4x over 4. And when we divide 4x by 4, we get x. So we have now shown that g of g minus 1 of x is equal to x. So if we apply both functions, the function and its inverse to x, we end up back at x, which is demonstrating that it's working as an inverse. And if we look at this one here, where it was g minus 1 on g of x, and again, when we did g followed by its inverse, it came back to where it started, and again demonstrating that it is an inverse. Please study the example, pause, think about what's going on, and see if you can apply it to the questions indicated above.